Welcome. Today we are going to be talking about ratio and proportional relationships. Specifically, we are going to focus on one of the models mentioned in the Common Core State Standards for Mathematics. First, you're going to discover how the tape diagram can be used by students to conceptually understand the meaning of ratio. Then you're going to see how this thinking tool helps students reason about ratio and proportional relationships so that they can solve real-world problems. Let's turn to the Common Core State Standards for Mathematics to define the tape diagram. In the glossary, the tape diagram is defined as a drawing that looks like a segment of tape. It is used to illustrate number relationships. In the Common Core, the tape diagram is also referred to as a strip diagram, bar model, fraction strip, or length model. In mathematics, in context, it's also called a fraction bar model, a percent bar, or a number strip. The first introduction of the tape diagram to illustrate a ratio relationship is in the unit Models You Can Count On. Notice how this water tank is shown and the gauge is clearly segmented and labeled. Let's take a look at another picture found later in the unit in the same activity. Notice how the graphic has changed? Both tasks require students to pay close attention to the part-whole relationship. The tape diagram offers a visual support that helps students make sense of the problem and find a solution. Let's take a look at another activity in math and context. In this unit, called Fraction Times, students conduct a survey to find about their favorite color. Then they take the survey from the frequency table and color the segmented bar. The tape diagram continues to be useful as it is connected end to end and turned into a continuous band of color. This continuous band of color is then used to create a pie chart. When students have these multiple representations in front of them, they then are asked to compare and analyze the results. Let's look at these student responses. Notice how they use the various representations to help them with their discussion. Some students use the frequency table to talk about a set of votes. Another student used the tape diagram. Since one segment of the tape diagram represents one vote, the tape diagram then can be used as a length model. With a circle graph, shape can be used to help analyze. Students can use area and as they talk about the size of the section. In the earlier grades, students also learn that 1 degree of measuring an angle is 1/360th of the circle. So the shape of an angle also proves helpful. Then, if you notice on the bottom, the students have now used symbolic numbers to represent the results. Later, students are asked to compare and contrast the various representations, how they're alike and how they're different. Let's look at one more example. This rich task comes from Fraction Times. Although students can use many strategies to solve this problem, I want to show you two students that used the tape diagram. Notice in the samples we've looked at how students are using the horizontal and vertical orientation of the tape diagram. So far we've been discussing the use of the tape diagram to represent and visualize part-whole relationships. Notice when the quantity within the ratio, the two quantities have different units, it often proves confusing for students. How would your students solve these real-world problems? When students don't have a chance to work with visual and spatial representations of these models, often they will choose the wrong strategy. Some students may even use the same strategy to solve both of these problems. Let's take a look at how students use the tape diagram to solve. In this animation, the student first labeled the two quantities. Research has shown us that this proves to really aid in the understanding of the problem. Next, the student labeled information from the problem. I want you to watch and see what the student did next. When the teacher observed the student working this problem, she asked him to explain his thinking. The student explained that he first labeled the bar with 4 equal parts. He explained that each part represented 25%. The student then since the student then has an understanding of the length of each segment, the student drew one more segment on the end of the bar to show that it was a 25% increase and labeled it 125%. Next the student had to figure out the price of the 25%. The student divided 96 by 4. When asked why the student chose to divide it by 4, the student pointed to the 4 segments and said that each segment counted as 25%, so there were 4 segments, so he knew that he was to use 4. After the $24 was found, the student then added it on to the 96 to find the increased price. Let's take a look at our next student. Notice the student drew the tape diagram and labeled. Next came the information from the problem. At this point, the student divided 96 by 4. But as the student labeled the other segments, the rest of the segments, the student discovered her error. She then divided 96 by 3. When asked why she chose 3, the student remarked that the tape diagram showed that the $96 was only 3 out of the 4 segments. It was only 75% of the price, so that way she knew that she had to use 3. So she then added 32 to 96 and ended up with the actual price. To check her answers, the students then put in all the equivalent ratios and labeled the entire bar, labeling each segment. As students increase their understanding of ratio and percent problems by using that tape diagram, they begin to feel very comfortable manipulating the equivalent ratios, often using mental math. Let's take a look at Craig's reasoning about a real-world problem that he faces it when he visits a restaurant. Is this how you figure a tip? Craig found the 10%, doubled it, then put it on his total. He knew he had to leave $48 for that waiter. Now, if you look at this problem, the word altogether, if a student had learned the strategy for the keywords approach, altogether wouldn't be useful in this situation. The tape diagram enables students to think about the numbers in the problem, how they relate to each other. The last example is a problem that students find difficult to understand. This student drew the bar, labeled the words, put the information in that he understood from the problem, but at that point he had to really sit and think about it. So he drew this first. He remarked that $200 was 50% of the price. Then he was able to mark $20 as 5% of the price. So now he knows that $220 is 55% of the total price of $400. But that's not what the problem asked him. So then he was able to label the bar with the actual discount and color it in. The writing team of the Common Core State Standards for Mathematics have shared further information and insight in the progression documents. From the progression document titled Ratio and Proportional Relationships, grades 6 and 7, we are reminded that students need to spend time developing a conceptual understanding of ratio and proportional relationships using the models. As students become familiar with relationships among equivalent ratios, their strategies become increasingly abbreviated and efficient. Remember, it is important not to rush to that proportional equation, rather to give students time to use the models, develop a deeper understanding, so when they do that symbol manipulation, they do it with meaning. Thank you for joining us today. We hope this webinar will help you with your planning as you work to implement the Common Core State Standards for Mathematics and the Mathematical Practice Standards. If you would like more information regarding the other models, interactive materials, curriculum, or additional professional development, please visit us at mathandcontext.eb.com.